Before there were stars. Before there were galaxies. Before there was even time as we know it. There was darkness. Then, 13.8 billion years ago, something incredible happened. A universe exploded into existence in what we call the Big Bang. And with it came the first light. Not the light of the sun. Not the light of stars. But a faint, whispering glow, invisible to our eyes. Stretching across the cosmos. This light still exists. It's all around us, everywhere. And NASA calls it the cosmic microwave background, the oldest light in the universe. What is the CMB? Think of the universe as a giant oven. At first, it was hot, dense, and opaque. Light couldn't travel freely. For the first 380,000 years, the universe was like a foggy furnace. The particles of light bounced around endlessly, trapped by the dense soup of particles. Then, as the universe expanded and cooled, something amazing happened. Atoms formed. The fog cleared. Suddenly, light could travel freely. That first light is the cosmic microwave background, a snapshot of the baby universe. It's the earliest light we can possibly see. Nothing older has ever reached us. And though this light has traveled billions of years, it hasn't disappeared. It has cooled as the universe expanded, now barely 2.7 degrees above absolute zero. A faint microwave glow, whispering the secrets of the cosmos. How was it discovered? In 1965, two scientists accidentally stumbled upon this ancient globe. Arno Penzias and Robert Wilson were working on a radio antenna and kept hearing a mysterious, persistent static. No matter where they pointed, the noise remained. At first, they thought it was interference, pigeons, equipment errors. But it wasn't. It was the echo of the Big Bang itself. For this discovery, they won the Nobel Prize in Physics. Since then, NASA launched several missions to study this ancient light in detail. Wilkinson Microwave Anisotropy Probe revealed tiny ripples, the seeds of galaxies. Planck satellite produced the most detailed full-sky map ever. These tiny temperature variations, just millionths of a degree, tell us how the universe evolved and where galaxies would eventually form. Why it matters. You might wonder, why should I care about a faint microwave glow? Here's why. Every galaxy, every star, every planet, every atom in your body traces its origin to this light. Those tiny ripples in the CMB weren't random. They dictated where matter clumped together, eventually forming stars and galaxies. Without them, the universe would be featureless. No Milky Way, no Earth, no life. The CMB also helps scientists understand the age of the universe, its composition, ordinary matter, and dark energy. The universe's shape and expansion. Confirmation of the Big Bang Theory itself. In a way, the CMB is the universe's baby photo. It's a record of the moment everything we see today began. The edge of the observable universe. When people ask, where is the edge of the universe? The CMB is the closest answer we can give. It isn't a wall. It isn't a cliff. It's the limit of what we can see. Anything beyond this light, we simply cannot detect it. Because light from earlier times never reached us. The universe might continue forever. But for now, this faint glow marks the edge of observable time. It's a cosmic boundary, not of space, but of human knowledge. Big impact. The cosmic microwave background is more than a faint microwave glow. It is a message, a whisper from the beginning of time. A record of how everything we know came to be. A map that connects us to the origin of the universe itself. Next time you look up at the night sky, remember this. Every star, every galaxy, every atom in your body, all traces its story back to this ancient light. NASA didn't just discover the oldest light in the universe. They uncovered our cosmic origin story, and it's still shining, all around us. If you want to see more incredible cosmic discoveries, subscribe and join us as we explore the universe like never before. Because the universe is not just out there, it's inside every one of us.